So much. Hey everyone, thanks for having me coming at you live from my kitchen here in sunny Berlin. And we're going to see how a live presentation goes. So let me go ahead and share my screen and see if that's working. Can someone just give me the thumbs up to make sure we're all good, or let me know? All right, I'm gonna hope we're all good. So, as I said, my name is Brian Egan, and I am a software developer here in Berlin. And I generally work on a lot of like open source bits for Flutter and Dart. And one of the things that I really like, and I really like teaching people about, is testing. And what happened is about a year or a year and a half ago, I wrote about 8 or 9 articles for the cookbook, the Flutter cookbook that you can find on flutter.dev. And I wanted to kind of talk through those articles in presentation form. And what I call this is the Dart and Flutter testing, the starter pack. And so if you're familiar with testing and you've done a bit of widget testing and things like that, I'm going to kind of maybe be a little more introductory, but hopefully provide some tidbits along the way. So if you're already into testing, this might not be quite as useful, but if you're just getting started with testing, this is really meant for you. And yeah, I hope you like it. So the first thing that I just want to cover is why testing. So I think when you're starting out with testing, a lot of times you're like, hey, I'm writing these little apps, I'm running them in my web browser or in the emulator, and they're, working. And, when I want to try something, I just, run the code and make it work. And that's totally cool. Like if that's how you're working and you're getting started, it's totally great. But I think it can be really nice to consider as you want to make your apps a little more robust, and as you maybe want to get them ready for a commercial release, or if you are maybe writing something that's kind of tricky, tests can be really helpful. So the reasons that I say for testing, the first one is just better user experience, right? And so your users are, in general, they are going to experience, if they experience bugs, they're going to have a bad time, right? And the thing about testing, and what's been proven by actually studies that they've done of comparing teams who perform testing strategies versus teams who don't test their stuff, is that those teams that test end up writing software with fewer bugs. Therefore, those bugs don't get shipped to your users, and therefore your users have a better user experience, right? If they encounter bugs, they're going to have a bad time. If they don't, they're going to have a good time. So testing has been proven to cut down on the number of bugs you ship. So that's good for your users. The second one, and this is, I think, a really important one for someone like myself. And again, these are all sort of situations that depend on where you are. But one of the things that I've done a lot in my career is I've joined teams where there's already a pretty large code base. And I would either need to go in and work on either a screen or maybe some logic. And I would need to work on that screen, but there was a really interesting, and I found really big difference between code bases that had tests and that didn't. So say that you have a standard problem with one of the screens in your app or one of the widgets in your app, and you want to go ahead and make sure that you fix that problem, but don't cause any new problems when you're making that change. Now, if in the first scenario, if you don't have any tests, how would you perform that? Well, it would be, once again, like what we talked about before. You would probably make the change, run the emulator or run the app, and then go through the app manually and see that it works the way you want it to. Now, the problem is that if you weren't the person who originally wrote that screen, or maybe you did write that screen, but you're coming back like 6 months or a year later, you might forget to test all of the different edge cases that you took care of the original time. So if you think about the same scenario where you have tests, what you could do is you could simply go into this screen or widget or whatever's having an issue. You could run the test suite to make sure that everything's passing. You could add a test case to say, to exercise or to run the code where you expect the error. Then you can run those tests and make sure that it's actually failing. And then you can write a test and make sure that everything's passing. And this gives you a lot of confidence as someone who is new to a code base or a part of a code base, or like I said, a code base that you just haven't touched in a while, to make sure that when you make these changes, you make them in a safe way. So that's a really big win. And finally, although it seems counterintuitive, testing actually will save your company money overall. And that seems counterintuitive because tests take time to write, And, so we assume, okay, you took all this time to write these tests, that must cost more. But as I mentioned with the better UX section, what they found is that the biggest thing is if you catch more tests, more errors at the beginning of the development process, even if it takes you a bit of extra time to write those tests, it's actually faster over the lifetime of a feature than maybe shipping a feature with a couple of bugs and then having to go back and context switch back into solving that problem, then context switch out, and then context switch back in and solve another issue. And so actually you can save yourself some money over the long run. And kind of one I didn't put on here, but if you're just getting started with coding and you're just getting started with Flutter or Dart, tests can actually just be a nice way to keep your own sanity, right? And what I mean by that is that if you're just trying to figure out how something works, writing a test for it is actually a really great way to understand how your code is working and what's going on underneath the hood. So I really recommend testing, and I recommend it for those reasons. So that sounds good, Brian, or maybe not, hopefully it does. And so let's go ahead and get started. So when I first started out with testing, and I'm sure a lot of folks have this same thing, is that there are just so many terms. So for example, there's unit tests and widget tests and integration tests. There's service tests, contract tests, functional tests, acceptance tests, UI tests, end-to-end tests. And then there's this whole like sort of thing with test doubles of dummies and fakes and spies and subs and mocks. So there's just a lot of lingo here. And what I want to do is just try to break these terms down so that you can understand them, or hopefully in a way that they're easy to understand. So what are unit tests? Well, when I first heard this term, my first question was like, what is actually a unit? So a unit test is basically going to test a function, a method, or a class. And what you're going to do is you're going to be testing that function, method, or class behaves in the way that you expect it to in certain circumstances. So a couple of examples of unit tests might be, say you have some form validation, and you want to make sure that the email address or password that the user has entered is actually a valid email or username. Now, the other thing you might want to do is you might have like some data. Perhaps you get some data from a backend, or you get some data, oh, excuse me. So say you maybe get some data from a backend like Firebase or your HTTP server. That's generally going to come in the form of JSON, and you might need to transform that JSON into a proper Dart class. So that's another great time to write a unit test, because you could test a method or a constructor that converts a JSON map into a proper class. So hopefully that kind of illuminates a little bit of what a unit test does and some examples of where you can apply unit testing. Now, when it comes to Flutter, we actually have another type of test as well, and this is called a widget test. And this is essentially a unit test for a widget, is the way I sort of think about it. So you're still testing a single class, a single widget usually. And what you're doing is you're just testing that instead of maybe a function returning the right validation logic, you're going to ensure that a widget does what it's supposed to do. So does a widget display what you would expect when you first render it? Or when a user taps on a button, is the display updated in the correct way? And what happens, for example, maybe when you pass new data into a widget, is the widget redrawing with the correct data? So these are the types of things you can do within widget tests. And to make widget testing easier, the Flutter team actually provides a package called Flutter Test that provides mechanisms to actually write and run widget tests. That package, we'll dig into it in a little bit, but basically it includes just helpers and goodies so that you can build your widgets and then look through the widget tree to like find certain widgets to make sure they're there so that you can verify, hey, does my widget display what I expect? Or it also provides utilities for tapping on things. So you can say, hey, when a user taps on something, does it update correctly? So widget tests are really great. They're sort of like a specialized unit test that tests widget classes. Now, in Flutter terms, there's another type of test that they discuss, which is called integration tests. Now, this might be a slightly more confusing term because a lot of people use the term integration test, and it can mean a lot of different things. So traditionally, the way I have thought about integration tests and the way I've generally seen them referred to is that you're trying to test the integrations or the connections or the interactions between different components in your system. So you might be trying to test, for example, that your Dart code can properly talk to a web server, download some JSON data, and then parse that JSON data correctly, all in one test. So rather than just testing the parsing function, you might be testing the entire thing, all integrated together. So you're going to test actual components against actual services. And that's why it's called an integration test, right? Because you're not testing this thing in isolation away from anyone else, which is usually how you test work with unit tests. But this is actually going to really say, like, hey, can I integrate with the operating system or web services or Firebase all correctly? When it comes to Flutter, they refer to integration tests in this way, and they say that basically an integration test means that you're going to actually run your app on a real device generally, sometimes an emulator, but generally it's best if it's a real device. And you're going to be testing that your app works together as a whole, or that portions of your app work together as a whole. So rather than testing an individual widget, this can really be thought of as testing all of your widgets and seeing how they integrate together or work together. So this is sort of the difference between unit testing, widget testing, and integration testing. Is unit tests and widget tests, they kind of isolate and test either a single widget or a single function or a single class, whereas integration tests are, of course, like I said, going to be talking to external systems and external things, and we're going to be testing the interactions between those. So now we lead to my favorite part of the presentation, which hopefully sort of visualizes the difference between unit tests and integration tests, right? So this is a great one, right? Like the person has correctly installed this thing on the door, but the integration with the actual door slot just makes no sense, right? This door, yeah. So unit tests are passing, but the integration test is falling apart. This is another amazing one, right? So you have a couple of different units, right? You've got your doors, and then you've got your gate, and each of them is probably working correctly by itself, right? But now, of course, you put them next to each other, and the integration is breaking apart. The unit tests are passing, but the integration test is failing. And this is probably my favorite one. I just don't even know who installed this faucet. I mean, this is just crazy. So yeah, this is sort of meant to be a visual representation of the distinction. You know, that sink would work totally fine on its own. That faucet would work totally fine on its own. But when you integrate them together, they create maybe the most chaos I've ever seen in a bathroom. So that is insane. All right. So when we talk about these types of tests, you know, you might say, okay, we're supposed to have some widget tests and some, unit tests and some integration tests, but how should those be composed? And so generally what folks talk about is the testing pyramid. And sort of the general advice from the testing pyramid is that you want to have a lot of unit tests, you want to have fewer integration tests, and then you want to have a few UI tests. And when I use this language here, I maybe should have lined it up a little closer to the Flutter documentation, but essentially what I mean is a lot of unit tests, unit and widget tests, in my opinion, and then the integration layer. Those could be things, like I said, like actually talking to real databases and things like that. And then really you should only have a few tests, in my opinion, that are UI tests that are run with the Flutter integration testing tools. And the reason is, for this general advice, is that unit tests run very fast and are very fast to write. Integration tests take a bit more time to write and a bit more time to maintain. And UI tests, where you're actually launching the application on a device and you're driving through it, those are by far the slowest, and they're also the most brittle. So you have a lot of things like what people call test flakiness in that case. So what that essentially means is that unit tests are the cheapest to maintain and run, and UI tests are the most expensive to run and maintain. And although you maybe, excuse me, get the most value out of your UI and integration tests, because they come with so much cost, they can actually slow you down if you have way too many of them. So this is why it's generally advised that you have a lot of unit tests and then fewer integration tests and even fewer UI tests. And the cool thing is, once you get these your testing in place, then you can integrate into a pretty standard continuous integration workflow. So once you actually have your tests in place, then when you actually push code to your CI or to GitHub or wherever it might be, what it can do then is you can trigger some automatic processes, right? And so at that point, you can set up a CI like Travis CI or CodeMagic, of course, to actually run these different things, these different tasks. So in this case, this is where tests are really nice, because you could have your CI run all of your tests and make sure that none of the tests fail before it even tries to either build or deploy your application. And so putting tests as part of your CI pipeline, your continuous integration pipeline, can be really, really powerful overall. because, like I said, it allows you to sort of check your code and every branch of your code to make sure it's safe to merge and safe to ship to your users. Okay, so that is sort of like the high level overview of the types of testing that Flutter provides and how to like think about which types of tests to write and how many of them to write. Now, what I'd like to do is just jump in and do a little bit of live coding and kind of show you how to maybe write these tests and show you the test package and the types of things that are included. So we're going to pop over to my main screen, and we're going to go ahead and try to write a little login screen. So in this case, I've basically just got the standard Flutter boilerplate going, and I've launched it as a desktop app here on the right-hand side, Mac OS desktop. If you're not on this hotness, we were talking about it beforehand, the desktop stuff is just great. It's so good. You can run all these apps. You don't need an emulator running or anything, and it's all good. Okay, so the first thing I always do with these demos is just delete a bunch of comments because they just drive me a little bit nuts. So I'm just going to do that. But let's go ahead and get into our testing strategy. So the first thing you'll need when you're testing is you're going to need either the Flutter test or the test package. And these will provide the tools you need to write unit tests and widget tests. So then what we want to do is, if we're writing a login screen, we might talk about the types of things we want to test in this case. Now, there's a variety of things you could think about testing. So for example, when you log in, you're generally going to need to make some sort of HTTP requests to your backend to see if the email and password are valid. So that would be something you could think about testing. And that could either be a regular unit test or an integration test, depending on how you wanted to make it work. But just to get things started and to keep things a bit simpler, I think let's go ahead and start with writing some validation tests. And so we're going to create a form that will accept a username and a password, or an email and a password rather. And we'll have two different functions, one that tests whether an email is valid and one that tests whether the password is valid. And so let's go ahead and think about how we would do that kind of thing. So just to get our Flutter stuff started and kind of up and running, let's go ahead and create a form of some kind. Okay, so I'm just going to quickly blow through this. I don't want to take up too much time going through this part. Oh no, I totally botched all my comments, didn't I? Boom. Wait, one less. Okay, sorry, just getting rid of those comments. And we've got our My app, and it's creating a My homepage. We don't want any of this stuff, so let's create just like a login page ourselves, and we'll take care of all that business. Don't really need any theme data. Login demo. Okay. So then to create a login page, we're going to go ahead and just create a stateful widget. And we'll call this login page. And it doesn't need to accept any parameters for now. But what we'll need to do is we'll need to go ahead and create a little form. So let me just go ahead and save this and make sure, yep, we got nothing. Perfect. So we'll need a scaffold with an app bar. Login. Okay, now we got something going. And now all I'm going to do is just create a super simple form, and it's going to just essentially have a couple of different fields to it. It's just going to have email and password. So in that case, then we're going to have a body for our scaffold, and it's going to be a form. And that form is going to have a few different children. So we're going to need a column. And then of course we'll have some children, and the first one will be a text form field. And this will take in the email. So we're going to go ahead and give it some input decoration. With hint text email. All right, looking good. And then we'll need another one. Oop. Text form field with the password. Okay, cool. Let's go ahead and just wrap it with some padding. Nice. All right. Finally, we'll need a button. So let's just go ahead and use the old raised button, and then child will be some text, login, and then on pressed. Okay, so then we'll need to do some stuff here in on pressed, right? We'll want to validate the form fields, and then if they're valid, perform the login. Cool. So how do we go about doing the validation part? So this is where we can start thinking about how we would actually even start to write tests for this. So let's go ahead and do more of a test-driven development approach for this part. So if we pop into our test folder, we can just go ahead and create a new test file. And I'm just going to call this like validators test. Oh, sorry, it's supposed to be a Dart file, validators test. Okay, now in order to get started with testing, all you actually need, once again, like any Dart app, its entry point is just a main function. And you can just start writing tests actually. So you use the test function and say email validator, or maybe email is valid if it contains @ symbol, for example. So this is just our very first test. Now this is actually going to be using the Flutter test package. So I'm going to go ahead and import that. And this test allows us to basically say, hey, this is a test. This is a description for the test. And this is the actual function I want to run to execute the test. So then inside of here, we can actually start to exercise our email validation logic, right? And so now what we can do is we can say final email equals a@b.com, for example. And then we would expect the is email valid function, when we pass it that email, would return true, because we actually do want it to have, we want it to be true because it contains the @ symbol. Now, this is going to be a really simple validation strategy. In general, you'd want to like actually probably go out and find or write a regex that does this properly. But for now, just know that we're going to do a really simple implementation, and the focus is more going to be on setting up these tests. So what have we done here? Well, what we've done is we've now inside of a test, you can write an expect. And so as I said, the expect is basically going to be a function, and you can pass through two things to it. The first is the actual value, and the second thing is either the value you want it to be or something called a matcher. So in this case, we could actually write something like expect 1 is equal to 1, right? As simple as that. Or 1 + 1 is equal to 2. So just think about the expect. It takes in the actual value versus the expected value. And that's how you can understand, and that's how you know if like what you're expecting is actually correct. So in this case, we're trying to expect that when we call this is email valid function with email, that it'll return true. Of course, this is email function doesn't exist yet, and so for now, it's not really going to work. So we'll go ahead and implement that later, and that's the whole point of TDD. So now we'll just have another test like email is invalid if it does not contain the @ symbol. All right, so then our email in this case will just be ab.com, and we'll expect is email valid to be false in this case. So now we actually need to write these functions. So what we're going to do is we're going to create a new Dart file, and in here we'll just call it validators, and we're going to write that function, right? So right now, if we try to run the test, they just won't run at all because we've got errors and it just won't even run. So we're going to go ahead and implement this function. So this is going to be a function that returns a Boolean and takes in an email string. Now, for now, we're just going to like want to get the test running. So I'm just going to return null, and I'm going to go ahead and switch back to my tests and import my validators.dart file that I've just created. And now I'm going to run my tests, and they should all fail, assuming that I did not implement anything. So, and that I wrote my tests correctly. Yeah, so let's see what happens here. The first run of Flutter tests can sometimes take a little while as it's kind of getting everything set up, but luckily the subsequent runs will be much faster. So it looks like this one, right, because it expects true, and what we've actually returned is null, that we can see our test has failed. And the nice thing is if you run these tests from IntelliJ, which you can do by either clicking on these buttons and hitting run, or with a keyboard shortcut. So on Mac, it's just Control-Shift-R, and you can basically run tests really quickly in that way. So we've got these tests, they're in place, and they're failing. But hopefully you can start to see that the test function defines the test, the expects will help us basically verify that what we expect to happen does in fact happen. So now let's just go ahead and write this function so that it passes, right? So in our case, we've got really simple logic. So we're just going to say, does this email address contain the @ symbol? And that's all the logic we'll need. And then we can run our tests, and hopefully everything will work just fine. Boom. All right, we're good now. So what's cool about this is now that if you wanted to change or extend your logic, like I said, to make sure that you've got like, this is a really simple version of a validator, but maybe you have like a much more complex email validator. What's cool is you could have these tests in place and make sure that they still pass as you continue to extend and refactor that email validator. So this is where it becomes really cool for making safe refactorings. One other thing I like to do myself is I like to group my tests, and this basically would just say like, is email valid? So basically you can group all your tests together that are related to a single topic. And so since both of these tests exercise the is email valid function, I'll put them into a group together that I just called is email valid, or you could even say like email validation, whatever you want to give that name you want to give that group to help you understand what it's actually covering. But now when you run these tests, you'll actually see that they're kind of grouped together nicely down here in the test results. Okay, great. So you can see that email validation, and when especially you're looking at these things on your CI, these groups can be really, really helpful because it can help you like limit down exactly what you're looking for right away. So this is sort of the basics, the bread and butter of unit testing in Flutter. And in this case, as I said, we're testing, the unit that we're testing is an individual function, and we've written 2 tests for it, and we've grouped both of those tests together. So this is about as simple as it can get, but this is also really nice because, as I said, maybe if you didn't have this test and now you apply it to your UI, this validation logic to your UI, say that you got this wrong, and say that the user was actually entering a valid email, but they couldn't log in because the email wasn't valid, because your UI was blocking them. So that's why, like I said, it's nice to be able to pull this kind of logic out of your UI and even into a separate function that can be easily tested. So let's go ahead and look at the next level of testing, which will be widget testing. So if we go back to our main file, right now we aren't doing the validation and performing the login. So let's just go ahead and see how we would do that ourselves, right? So if we wanted to write this ourselves without any tests, right, we would just do the classic thing of implement it and then drive it on the device to see if it works. Like I said, that's a totally valid way to do it. But if this might be a screen that you're going to forget about or not come back to for a while, or you've got a lot of members on your team and different members are going to be working on different things, doing this sort of like manual checking along the way can get a little tedious. But we'll start with it to show how it could work. And then we'll implement a widget test to show what an alternative might be. So in this case, we're going to need a form key. So basically what this is going to be is this, if you haven't worked with forms before too much, in the cookbook, I've actually got another good article on working with forms. But essentially what you're going to need is a global key, and you're going to need to pass that global key to the form widget. And then that will give you access to the validation. And then what we're going to need to do is on the email field, we'll need to implement the validation. And so what you have is on text form fields, you have this validator function. And this will pass through the email string that the user has typed in, and it will allow us to actually call our function. So then we can say, okay, is email valid? If it's valid, then from this function, we don't want to return anything. Okay, in this case, what we want to do is we just want to return null. Because the validator function, the way it works is if you return a string, it'll display that string as the error, or if you return null, it won't show anything. So if the email is valid, we don't want it to show anything, and therefore we'll return null. It's a little bit of a weird API, but this is how it works. And now, if the email is not valid, we'll want to say email must be valid. So we'll show them this error message. Now, when the user logs in or clicks the login button, we'll actually want to perform that validation. So what we can do is we can use that form key that we set up earlier, and we'll say formKey.currentState.validate. And what this will do is this will go through and it'll run these validator functions. And I haven't applied one to the password field just for the sake of time, but we could have one there. It'll essentially run through all of these validator functions. And if any of them return a string, then it will know that the form is something is invalid. If everything returns null, then it'll know that validate that everything is valid, and this will return true. So you can see that the validate method, if you just like go to the documentation, it's just going to return a bool or false, bool true or false, if something is valid or not. So a little bit beside the point, but now what we want to do is we'll want to say, we'll actually want to do the login, but we don't want to quite, for the sake of time, we don't have logging in. We don't have quite enough time for that. So we'll just go ahead and print logging in if everything's valid. So we're going to go ahead and just going to do a restart here. I'm going to pop over to my emulator. I'm going to try to log in. All right, cool. Email must be valid, a@b.com. And then we try to log in. And now we can see that that message went away. And if we look at our runner, we can see that it's logging in now. Okay, so that's cool. And now we know we can test it manually but like I said, we want to turn this into an actual widget test. So what we'll do is we'll go into our test, and we're going to create a new Dart file called login page test. And once again, we're just going to set it up with a main function group. I'm just going to create a login page, and I'm going to go ahead and import Flutter test to make that work. And test shows error message if email is invalid. So this will just be the name of our test. And here, rather than using test, I'm actually going to go ahead and switch it up. So remember before I said that Flutter actually includes some utilities for writing widget tests. And that utility is specifically the test widgets function. And what that'll do is that'll provide a widget tester. So instead of the second function just being a callback that doesn't take any parameters, Flutter's test widget function will actually pass through something called a widget tester to your second function. And you can use this to drive your app. So now in here, what we can do is we can actually start to write widget tests. So in order to write widget tests, the first thing we'll need to do is we'll actually need to basically set up the widget. So what we'll need to do is we'll need to do something called pumping the widget. So the widget tester provides a number of methods, and its job is basically, as I described a bit earlier, to either build widgets or rebuild widgets, or it is responsible for tapping on things or anything like that. And it's a bit unique because you have full control over the rebuild lifecycle in your widget tests. It's a little bit different than you might be used to. So what we're going to do is we're going to use the tester.pump widget, which is essentially going to build our widget for the first time. And we're just going to go ahead and build our full app. And then what we can do is we could just write expectations, right? So we can just expect that we find things within this page. So we could say, now, what are we going to look for? Well, the cool thing is that Flutter also comes with these things called finders. And so say we want to say, see if we can find that this page actually has a raised button on it. Well, we can say find.byType raised button. Okay, and this is going to be return something called a finder. And then, as I said, the second thing that you can pass to the expect function is, first of all, either the value you expect or something called a matcher, a test matcher. And this is basically a way for you to write custom functionality to create custom checks, essentially, on the value that's passed in. So what we can do is we could say finds one widget. So we could expect that our finder, this find by type raised button, finds only one widget, this login button. And now if we run this test, we should hopefully have a passing test. Once again, it can take up a little, oh no. Oh, that's very good. So this is good. So what I did is I messed up, and it's telling me exactly how I messed up. So basically all of these pump widget and everything else, they're returning futures, but I'm forgetting to await the future. So I've just done that. I'll fix that bug up, and I'll run the test one more time. And now it works. Cool. But that's not quite testing what we want. So what we want to do is we want to make sure that if the user doesn't enter any text and they press the login button, that the email, it says this message. So we'll go ahead and code that up. So the next part will say, so then what we're going to want to do, right, before we're not going to want to make any expectations or assertions. We're just going to go ahead and find this raised button and tap it. So what we can say is we can now say await tester.tap, and it's going to take in a finder. So tester.tap find the button. Now that we've tapped the button, you might think, okay, so we've tapped the button, Flutter has rebuilt the widgets, and now we can just go ahead and expect that find. And in this case, we're going to find some text, and we'll just go ahead and copy that directly. There's definitely a couple better ways to do it. Unfortunately, I think for time, I might not have time to do this, but yeah, you can say it should find this text, finds one widget. And this is what I thought would work at first, but I just wanted to let folks know that, once again, the way that the test framework works is that you have full control over when the rebuilds happen. So normally what would happen is you would call maybe some callback function, and it would call set state. And then Flutter will rebuild your widget, right? And then you would say, okay, I can look at that and see that it's updated. What's going to happen in the test environment is that you're going to call that update, it's going to call set state, but Flutter isn't going to call a rebuild yet. It wants to give you, as the tester, complete control over that. So anytime you change the state of a widget, usually by tapping or interacting with it, you also need to pump the widget one more time to make sure, and this will actually call the build function again. So now if we go ahead and run this test, we should hopefully have a working test. And so now you can actually have this, and this could run through, and anytime anyone made a change to this, this test could continue to run and make sure that they have the safety. Okay, so the final type of tests are UI or integration tests. Just for lack of time, I don't think we have enough time to jump into those. But as I said, I've got a lot of documentation that I've written for the Flutter cookbook, and I've got step-by-step examples of how to write and recipes of how to write tests for that. So I think that concludes the demo, and hopefully that sort of introduced you to the utilities that the Flutter test package and the test packages provide out of the box, how to write your first unit tests, the types of things you should be unit testing, and also, like, the composition of your tests, from like having more unit tests into fewer UI tests, and how that can all be integrated into a CI. So yeah, if you're looking for further reading, like I really did spend a lot of time on these cookbook recipes. So yeah, I don't mean to like overhype them, but I think hopefully this talk and these recipes are really targeted at folks who are just starting to get into testing with Flutter. And I've tried to work with the team to make sure that they're hopefully clear and easy to understand. And so please definitely check these out as a way to get some real examples and real samples of how to write some tests. You can also see a bunch of different tests in a bunch of different experiments or libraries on GitHub. And so I'll post up some of these, but these are really nice to look at if you're kind of moving beyond like the basics and you want to see like, how does like maybe a larger Dart library or maybe a big Dart application, a Flutter application actually write tests. All of these repos have really kind of comprehensive tests, and yeah, you can take a look there. Thank you so much.
All right, thanks. Community got a couple of questions to you, Brian. Thanks for your talk. So the first one was, what are those fancy fonts? Especially what's about the curved font in your IDE?
Oh, that is a font. Yeah, that's an old trick. I gotcha. That is operator mono. Yeah, that is operator mono. I'm a huge font person, and so I play around with a lot of different fonts in there. I just want to show this because I think it's important.
Yeah, it's important.
It's important, yeah. So I basically have operator mono, and I've like patched it with the nerd font, so you can use like Powerline and stuff. But I've also like just fallen in love with this new font called Mono Lisa, and it's just beautiful as well. So I don't think you can go wrong with either of these. Ew, it looks pretty bad at that size, but maybe we could bump it down to like 13. It's also really good. So yeah, if you're looking for some new fonts, operator mono, it's kind of expensive. I didn't pay for it. And Mono Lisa, I did, and it's really good as well. So yeah.
I think you can tweet it or something like that.
Yeah, yeah.
So the other one is more technical. The second question is it possible to implement some functional programming paradigm to test apps with Flutter? From your experience, maybe.
So it just depends on how far you want to go. Like I've actually gone with some pretty crazy experiments where like I've literally had like a completely stream-based architecture, and even basically what the stream was delivering was a stream of widgets actually. And I felt like I was really fighting against the framework in some ways. And so even though I really love a lot of functional techniques, and I make use of a lot of functional techniques, such as like immutable data, pure functions, I still believe we're in essentially an object-oriented language, and Flutter is written in an object-oriented way. And so I still tend to write a lot of my stuff in more of an object-oriented style. Although, as I said, like I still rely on a ton of functional concepts even doing that. So it's kind of a bit of a mix, I would say. And you could try a fully functional experiment, but I think at the end of the day, you end up feeling like you're fighting the framework a little bit.
All right, thanks. I'd like to remind you guys that are watching that Ask Flutter Warsaw hashtag is for general discussion that will be held after the talks. And the questions that you asked directly to me are regarding this particular presentation or things that Brian said. Another question is, what about snapshot testing can you take the screenshots of the specific widgets and compare them to the new ones when writing UI tests?
Yeah. Yes. So in Flutter terms, it's usually called golden file testing. And so definitely take a look at that. Actually, that might be a good subject. I don't have a recipe up for that one, but Flutter is actually dope in that you can do that type of testing with golden files, essentially. Yeah, yeah. So.
Okay, another question. I think this is the one of the last or the last one is here you said that there are better ways to test for some messages popping up in one's app. What are those? Also, what if app uses some internationalization library? How should one approach this? And this was asked on the hashtag, but it's really regarding your presentation.
Yeah, yeah. So generally in the test setup and test environment, you can define the locale you want to use. And so I would generally, if you're worried about like making sure, you can just go ahead and use a specific locale for your test. So you can either do that by defining that as part of like a widget in your tree essentially. And so that's usually the way I would deal with it, is to define a specific locale and just test against that particular locale. Now, if you're thinking about things like, long strings and all that kind of stuff, it's funny, I actually don't have as much experience of trying to test like how long strings work in that. That actually might be something really interesting to chat about if anyone else has experience with that. But yeah, I would generally kind of focus it on that way. As far as testing like pop-ups and things like that, I think what I meant to be referring to is like in this tests, I'm not sharing my screen, but in one of the tests, I was just like finding directly by either text or by the type of like a raised button. Now, the problem with doing what I did there is like when it comes to like internationalization, right? You might have a different string, or when it comes to raised buttons, you might have like 4 raised buttons at a time, right? And so what you want to do is you want to find that exact piece of text, or you want to find that exact button that you want to click on. And so usually a better way than using find by text or find by type is to actually assign keys to your individual widgets and to use those keys to find things in your tests. Because that is going to be a bit more robust, because you can make sure that those keys are completely unique. And that will even be better than like setting your locale and finding by text, because you're finding exactly the right widget that you want to find.